So today's lesson is chapter 2, lesson 8, and we are estimating products. So we'll talk about what this title means really quick. So estimate means that we're giving an answer that's maybe not necessarily the exact answer. So the way that we do that is we round some numbers and then we multiply them. So remember how our essential question is figuring out lots of different ways that you can use to multiply. So we do that by, remember I told you like you have all these little tools in your tool belt now. So by the end of this chapter, you'll have tons of tools and you decide which one works the best for you for that any given problem. So all of these are not going to work with every question, but hopefully they will work for some of your questions. And so you just kind of have to pick and choose which things you're going to use. So the word product means we're multiplying, right? Because the product is an answer to a multiplication question. So let's look and see our essential question, which is the same as it has been. The strategies that can be used to multiply numbers. Here's your problem of the day. This one says, Jenny's twice as old as Manuel. Jenny's half as old as Gina. Manuel's 12 years old. How old are Gina and Jenny? Explain your solution. So this one's a riddle. So you have to answer one part before you can answer another part. So maybe on the side, you're going to make a little chart, maybe that has a J for Jenny, an M for Manuel, and a G for Gina. And the only given information that we have is that Manuel is 12. So I want you to go through and try to see if you can figure out on your whiteboard how old are Gina and Jenny based on that information. Jenny's twice as old as Manuel, so how old does that make Manuel?
Manuel's 24.
Jenny. Jenny would be 24. Hold on a second. Something's happening here. So Jenny would be 24. What about Gina? Someone else besides Karn Creek, because he just answered the last one. Hamza, what do you think? Jenny is half as old as Gina. So how old? 48. So because Manuel's 12, Jenny is twice as old as Manuel. And then Jenny is half as old as Gina, which makes Gina twice as old as Jenny. Okay, that was kind of confusing when you had to think about it. Well, it depends, I guess. Okay. Hold on. Hold, please. Hold on. There we go. Okay, so now let's go to the next. Oops, and the next. Hold on. It is. Where is my page? Well, there isn't an... Oh, there it is. There it is. Okay. So here is our question for Investigate the Math. How is rounding to estimate similar to using compatible numbers to estimate? So let me tell you the difference between those two things. Keep listening. Remember, we made a deal. You're going to listen the entire time I'm talking. I want to make sure you understand this. So when we round numbers, we go either up or down with the number. Usually we go up with the number. We usually round up a little bit, or it stays the same. Compatible numbers means we are choosing numbers that you can easily multiply or divide in your head. Okay, that's the difference between using compatible numbers and rounding. So here's a couple of things I want you to put into your notes. So here's the first thing. First thing you have to know is that an estimate is not exact. In fact, estimates are the opposite thing as an exact answer. So the problems we've been doing so far are asking you for an exact answer, the exact answer. 7 times 4, they want the exact answer. They don't want you to say, about 30, because that would be an estimate, right? Angelina. They do have a song for the rounding. Yep, and we'll use that once we get to that part. Okay, so the other thing we need to know is that a product is the answer to a multiplication question. There's my thing going. It's not trying to be nice to me today because we just reinstalled it. Now it's not trying to be nice. The product is the answer to a multiplication question. You write everything I write. So when our lesson today is on estimating products, that means that our answer is going to be not exact, and it's going to be the answer is going to be it's going to be a multiplication question that we're going to be having to answer. So here is the way that we are going to, this is what I want you to look at for today. We're going to be using some compatible numbers. So here's what a compatible number is, and when you hear me say this, you'll know what it means because it's in your notes. Nod your head if you remember hearing about compatible numbers in 4th grade. If that's something that makes sense, that you kind of remember. Because it should be something, it should be just like a term that you may remember from 4th grade. They're numbers that can be multiplied mentally.
Oh, yeah. Now I know that.
Today we're talking about multiplication, but other times we might use the word compatible numbers when we talk about division too, because there's a lesson later on that's estimating quotients, which means you're going to be estimating the answer to a division question. Today it's all multiplication, so we're going to use numbers that can be multiplied in your head or mentally. Okay, so there's our vocabulary. Now, when I say numbers that can be multiplied mentally or in your head, we're going to be talking about powers of 10. Do you remember that lesson from a couple lessons ago in our chapter? So powers of 10, any number that ends in a 0 is a power of 10, right? So those numbers, we talked about how easy they are to multiply in your head. Because all you have to do is multiply the non-zero part of the number, which is a basic fact. And then you just have to add the right number of zeros to the end of it, right? So when we're going to be doing some multiplying and we're not finding the exact answer. So here's the thing. Some of us may get a different answer than other people, but it's going to be close. So it's like if we looked at the clock right now and the exact time is 12:50, but if I looked at the clock and I said, it's about 1, I could say that, right? You could also say, it's about 12:45. Somebody else could say that, and that would be about right. Somebody else might even say, it's a little after 12:30 or something. So just depends on who you ask. So just like time, when we're talking about multiplication, as we look through the room and we're working on these problems, a lot of us might get one answer, and then some other people might get a different answer that's close. Now, if the answer that's in our book is 30 and you put 300, then that's not going to be a good estimate, right? That's going to be far away. So there are some, like once we get started, I'll show you, but there are some multiple answers sometimes, but they do have to be close. So 30 and 300 are very far apart. So here's the reason why we do estimates in the first place. An estimate helps you to check your answer when we get started with actually multiplying, which is happening later in this chapter, like tomorrow and the next day. So when we start multiplying and you get an answer, if you've been able to do an estimate really quick in your head, you have a number that's should be near the actual answer. So then, and you can do it really quick. Then when you actually multiply it out, you can check it with your estimate and make sure it's close. If your actual answer is way off from your estimate, then you know maybe you did something wrong in the problem and you should go back and check it. So it's kind of just a way to double check your work. That's why we learn how to do the estimates first, because that way, as soon as we get started with the multiplication part, you'll be able to use this lesson to help you check your answers. All right? Jameson.
What if our estimate is like the first answer?
Sometimes that happens. So if it's actually a multiple of 10 that you're multiplying, then your estimate might actually be the same as your answer, but that's not going to happen too often. Okay, so try this. I'm going to show you what I mean here. So if the question is 32 times 18, now I'm going to write it. That's written horizontally, but I'm also going to write it vertically like this. You know that once, like tomorrow and Friday, we're going to actually be multiplying numbers like that without using pictures, without using the distributive property. We're just going to be multiplying. So you're always going to write them vertically like that. So I'm going to change both of these numbers. And remember in the question up there says you could round, but you could also use compatible numbers. Personally, I think compatible numbers is going to be easier because basically all we're doing is changing it to the closest power of 10. That's what we're doing. So for 32, that means I'm either going to make it 30 or 40 because here's a number line. You need to see, hold on, don't yell it out yet. So 30 is here, 40 is here, and 32 would be about right there, right? Draw this in your, you don't have to draw this every time, but hold on. For this example, I want you to draw everything I'm putting up here. Just for this one example. So we know that 32 falls a little bit closer to 30 on the number line than it does to 40. So we're going to make that number 30. And that's going to be our compatible number. The other one, let's say we have 18, which means our numbers would be 10 and 20, right? Because those are the powers of 10 that both come before 18 and after 18. Now 18 on the number line is going to be about there, right? So which number is it closer to, 10 or 20? Nolan?
It's closer to 20.
Closer to 20,
10,
right.
Because even if you do if you think about it is 8 closer to 10?
Right.
Or 0?
So we're kind of rounding also, right? So we're kind of rounding too.
Yeah, another way you think of that is that because if it's closer to 10, the last digit, it's closer to 10, then you go up.
You're going to bump it up, right?
Because if it's
just like what Angelina said, 5 or more, you up the score, right? So if that second number is 5 or more, you're going to go up. 4 or less, you leave it the same.
Closer to 10, then it'd be closer to the higher.
Correct. Because the numbers we're looking at are powers of 10, so we're counting by tens. So now, if I went to multiply this, 3 times 2 is 6, and then I have 2 zeros that I'm going to put to the end of that number, and then I'm going to put this squiggly equal sign. The squiggly equal sign means about. So that it doesn't mean that 32 times 18 is not 600, because remember, we're not finding an exact answer, we're finding an estimate. So when you do the equal sign but with squiggly lines, it means that it's about that amount. So 32 times 18 is about 600. About, not exactly. So all we did was we changed those numbers to multiples of 10. So I want you to write that with a little star. Change to multiples of 10. You write everything that I write. Was that your question?
No, why not?
That needs to be there. Just in case you forget what we're doing. That's what we're doing. We're changing all the numbers to multiples of 10, either going up or going down, depending on where it's closer. Basically, we're rounding.
So we're just
That's why you see both of those words up there. You see rounding and compatible numbers in this question, because we're kind of using both.
I know, but for a lesson though, I'm just rounding.
You are, well, you're rounding because you're either making it up or down, but I'm not rounding to like 35. I'm rounding to the nearest 10, which makes it a compatible number because we like to multiply tens because it's easier.
That's easier.
Right,
Yeah.
right. So here's another example. Everybody have that stuff? We're going to have another one. Try this one. 98 times 83. So then I want you to write the question, and then next to it do your arrows, and then we're going to round those numbers to the nearest multiple of 10. So 98, where would you put that? What number are you going to change it to? Angelina?
100.
100, because 98, you could either go 90 or 100. So just like Angelina said, 8 is going to make you closer to 100. So we're going to make that one 100. Karnpreet, what would you make 83?
You make it 80.
You would make it 80. So now I'm going to do this. Any non-zero numbers, 1 and 8, I'm going to multiply. And then I add all the zeros that I need, which in this case is 3, right? Because there's 3 zeros in those other 2 numbers. So 100 times 80 would be 8,000, about. Well, 100 times 80 is 8,000, but 98 times 83 is about 8,000. Okay?
Oh, I see.
today's work is all estimates. They are not asking you to actually multiply anything. You are not getting an exact answer for anything. Hold on.
Can we multiply it
Hold on.
and then this be the wrong answer?
So I need you to look at your whiteboard. Then I'm going to give you several examples on the whiteboard, and then I want you to try it out, and you're actually going to hold up and show me what your answers are each time. So I'm going to have you write it, and then make sure that your answer is big enough for me to see it, and then hold your board like this. Don't show anybody. And then when I say show me, then I want you to hold it up and show me what you have, okay? And then I can really quickly see. You're not looking at other people's boards, you're just going to look at your own. So here's a question. Go ahead and grab one. There's some right here. No, I put them back. There's some over there. Try this one. Okay, watch this. Don't erase your board yet. Just watch, because I want you to see if you get the right answer. We're going to change 54 down to 50, because if I'm thinking of rounding, because the second number is a 4, I'm going to go towards the lower end. If it's 5 or more, you're going to go up to the next one. And now 68, oops. Hold on. 50, sorry. We got it fixed, kind of. 54 changes to 50. I did. And then 68 is going to change to 70, because that's closer to the 70. And then we're going to do 5 times 7, and we get 35. And then I have 2 zeros on there. Something I saw on a couple of boards was people who accidentally added 7 and 5 and got 12. So if you got 12, it's because you added, you didn't multiply. So remember the squiggly equal sign. Here's another one. Erase your board. Question number 2 for your whiteboard. Oh, I'm going to make it hard for you.
Yes, thank you. Yes, please.
You're welcome. You're welcome.
No.
Try this one.
No.
So 697 would change to 700. 43 would change to 40. 7 times 4 is 28. I did see a couple of 2,800s. But the only thing, listen, the only reason why that you wouldn't have got that one right is because there's 3 zeros here. There's one here, here, and here, and you need all 3. If you think about it, listen, that's 700, and you're multiplying it by 40, sorry. So that's that's a big number. It's going to be a really big number. Okay, erase. Nolan. Okay, so watch this one. 364 times 28. Now this one, we're going to have a couple of different, maybe somebody will do it in a different way, and then I can show you. We'll see. Let's see. So I'll give you a minute. See if you can figure this one out. On this one, before.
If you write on the side.
Sure. Sure. Before we correct this one, before I ask you to show me this one, there's a couple different ways, because this goes up to the hundreds place, right? And the other one, well, the last one we did went up to the hundreds, but it was only 3 away from the next hundreds. This one is a little bit different because it depends on which place you're rounding to, right? If you round to the hundreds place, you would get, hold on, if you round to the hundreds place, you'd get 400 times 30, right? If you rounded to the tens place, which is right here, which is what I saw some people doing, they might get 360 times 30. Remember how I told you that we would take like multiple answers for these? I would take either one of these as a correct answer. Now, we're doing powers of 10. So powers of 10 means it ends in a 0. So whether that's 1 0 or 2 zeros, that's up to you. Right. Okay, keep watching. Watch the screen. Boys in the back, watch the screen. So there's going to be a couple ways to do this one. I can multiply this way and get 12,000, right? Because I'm going to add those 3 zeros. And here, I might have to do a little bit of multiplication because I may not know what 36 times 3 is. So 6 times 3 is 18. That's 9, plus one more is 10, with 2 zeros. So this one is definitely the easier one, right? Because I could do that in my head. Hold on. The point is, listen. The point is that it's supposed to be mental math. And when I had to do this and carry the 1, it turned into not mental math anymore, right? Unless you know what 36 times 8 is without, right? Yeah. Now let me tell you this though. 10,800 is going to be a closer estimate to your actual answer because I didn't change the numbers so much. So 364, on the first one I changed all the way up to 400. And then on my second estimate, I changed 364 just down to 360. So the less you have to change your numbers, the closer your numbers are going to be to the actual answer. Okay? Let me say that one more time. Just listen. The more you change your numbers when you're estimating, like the further when you're rounding, the further the numbers change from the original number, the bigger your difference of your estimate and your actual answer is going to be. So that's the downside. The positive side is you really are going to want to get an estimate really quick. You're going to want to make it something that you could do in your head no matter what. So personally, I would change it to 400 times 30 just because that's an easier estimate for in my head. Now, but when I use this to check my work, so after tomorrow when we learn how to multiply this, and then we go to check our work, your estimate's going to be far off, but you should know that it's going to be somewhere in the thousands, above 10,000 at least, around 12,000. Okay? But it's probably going to be a little less than that number because I changed it so much. Okay? So you have to know that's what I was trying to tell you at the beginning, is that we may have more than one answer. So tomorrow when we go to grade, you're going to have to really listen carefully because somebody might say, I got 12,000, even though our answer might say 10,800, and I would still take 12,000. So here's what you have to do in order to get credit for those answers. This part's important for you. In your work today, when you're showing your work, this is what you need to show. And let me tell you why. Because tomorrow, if I go and read off of our answer book and it says 10,800, and you go, I got 12,000, can I put that? I'm going to ask you what numbers you multiplied together to get that number. If you have an answer that's different than the answer book, than the key that I'm showing when we grade it, I would still give you credit for that, but you would have to be able to tell me I multiplied 400 times 30. Okay, so if you write it down, you'll be able to tell me what you multiplied and be able to get the credit. If you don't write anything down and I say, well, how'd you get 12,000? And you go, I don't know, then you have to mark it wrong. You have to be able to prove to me the reason why you got a different answer than the answer book. Okay, so that's why you have to show your work by doing this. I know that it's mental math, but because it's the first time we're doing this, you have to show me your thinking. So you're showing me the way you're solving this so that if I ask you a question about it, you should be able to tell me. All right? Okay, look over at your math page. Oops.
Wait, I need to go back to my seat.
Okay. It's skipping by the one I want, which is right there. Okay. 3, 2, 1, 0. Oh, now you're going to have to owe me some time. Your paper's right there, so it shouldn't take that long. All you have to do is look. Remember, here is me looking from one thing to another thing. And I'm silent. I didn't even say anything. So all you have to do is look to your math paper. So example number 1 says that a pet store has 12 gecko lizards for sale. Each gecko lizard costs $92. About how much money would the store make if it sells all 12 lizards? So the problem is 92 times 12. Now, do you see what one way is right here? It says one way, round one factor. So remember what I just finished telling you? The more numbers you change and the further from the original number it is, the more different your estimate's going to be than your actual answer because you're changing the numbers so much. So one way is to just change the 12 to a 10 and then multiply and get 920. Could you do that?
Uh-huh.
See how they only changed one of the numbers that time? So if you can change one of the numbers into a power of 10 like that, like a 10 or 100, then it might be a better deal to just leave one of the numbers alone and make it 920 as your answer. So the estimate would be about $920. Nod your head if you see where we came up with that estimate. We only changed one of the numbers this time. So our actual answer is going to be pretty close to 920. Now, if we change the 92 to 90, would that be wrong? No, because it's an estimate. So what would we get if we change the 92 to 90? Nolan, what would we get?
You would have gotten 900.
You would just get 900, right?
That's the next example.
Oh, good. Well, look at that. We went ahead. So that's on your next part of it. Let me switch slides. So if I decided to change both numbers, oh, look at that. Another way, round two factors. So if we make 92 into 90 and 12 into 10, then what is he already told me that ours would be 900, right? So the first way actually is going to give you a closer estimate to the actual answer because we only changed one of the numbers. So the more you change it, the further from the actual answer you're going to get. So it's going to be a little more difficult to compare your estimate with your actual answer and make sure that you're right because it's going to be a little further away. But it would not be wrong. Okay, look at another way. So even another way is using compatible numbers. So we might change 92 all the way up to 100 times 10 and get 1,000. So if we were multiplying, if we bumped it up to 100 instead of 90, we would get 1,000 as our answer. So let's think of all three answers that we have so far. We have 900, 920, and 1,000. So this is what I was talking about. Tomorrow when we grade, we may have 3 people who have all 3 of those answers, and they are all correct answers because they're all estimates. Now the thing is that you have to make sure that you're writing your work so that we can see that how you got it so you could explain it to me. Okay? So if we used, I don't have a calculator here, so I'm going to pop the answer up on here. So if we actually multiplied it, we would get $1,104. That's what 92 times 12 is. 92 times 12 is 1,000. I'll write it here so it's a little larger for you. 1,104. 1,104. So if you're actually multiplying it, that's what you would get. So all of the estimates are a little bit less than the actual product because instead of selling 12 lizards like the question said, we were talking about what would they make if they sold 10. So there's those other 2 lizards that they would have to sell to make a little bit more money. So that's why our estimates were a little bit lower. Okay, let's look at, yeah, see how they have everything in the wrong order on this one for some reason. Okay, so here's your guided practice. So I want you to, now in the directions, let me flip forward to the next one. Sometimes, like this direction for numbers 3 through 8 says estimate by rounding. Then if you look at numbers 9 through 14, it says estimate by using compatible numbers. I want you to use whichever way works best for you.
So we can round?
So you can either round it or you can just look at it and make them both multiples of 10. Remember, because just like that last example, you could have like 3 or 4 different answers for each question. You just have to show how you got to the answer that you got to. Okay, so before you start the independent practice, I want you to do numbers 1 and 2. Compare them with your group. Make sure everybody in your group has the same answers, or something, or you can show how you got it because you may not have the same answers this time. Once you've done that, you can get started with the independent practice. Okay, and then I'm going to set the timer for you.